Okay, so before we start with 1.7, all right, we're going to fill out this. Your test will be Tuesday, Wednesday, right? Tuesday for A day, Wednesday for B day. All right, so we're only going to do the first 5. Do not X out the last 4. So we will come back and cover those at another time. All right, and it'll be another 50-point test for you. But we're only going to do 5 right now. So the first thing that I'm going to do when you walk in the classroom, I'm going to say, no, I'm not going to, let me shut the door. The first thing I'm going to do is you're going to clear your desk and I'm going to give you a little sheet of paper. And I'm going to say, write the first 5 common functions. So you're going to write constant function, constant, identity, absolute value, square root, and quadratic. Okay? If you write constant, identity, absolute, square root, and quadratic, I will mark this one wrong. Does everybody understand? I don't care if you put the word function on it, but you can't write just part of it. It's not absolute, it's absolute value. All right? Does everybody understand that? Then you're going to bring me that piece of paper with your name on it, and I'm going to give you this piece of paper. It actually won't be this one because I'm fixing to fill it out, but it'll be one that looks just like it, okay? And then you'll go to your desk and you'll fill it out and then you'll turn it in. Okay, so part of your points will come from, do you know the first 5 common functions? Has everybody got it? Mm-hmm. So what you might do is take the first letter of those and make up some sentence or something. All right? Can I absolutely square a quadratic? Boom. I just made that on the spot. All right, so make up your own, whatever. You can use mine, I don't care. All right, anybody got a question? Okay, so let's fill them out. So a constant function. Tell me what a constant is. Oh, hello, we've already defined that in here. A constant. Not one person in this class knows what a constant is. It's just a number, guys. It's just a number. Okay? It doesn't matter. It could be any kind of number. It could be a whole number. It could be a fraction. It could be a decimal. It could be irrational. It could be rational. It's just a number. All right? So what this is going to be is like f of x is equal to a number. But I don't want to put a number here because it can be any number in the world. So I'm going to put an a. For any. All right? F of x is equal to a. Now, when I graph it, like if you graphed f of x is equal to 4, that would be a horizontal line where y is 4. Okay? If you said f of x is equal to -2, that would be a horizontal line where the y value is -2. All right? So really all I want is just a horizontal line. Okay, just a horizontal line. Now, I want to know what the domain is. The domain is the x's. Do you agree? Mm-hmm. So as long as I know this graph, I can read my graph and find the domain and the range. All right? The domain, I'm thinking about the x's. Where does this graph lie on the x-axis? Where does it go? Well, it goes all the way to the left. What would that be? Negative infinity. To all the way on the right, which would be positive infinity. So we're using interval notation. Negative infinity to positive infinity. That's my domain. Any number in the world, that's what it can be. Well, what about my range? My range is my y value. Anybody know what my range is? Yeah, it's a. That's the only thing it is. F of x is the same thing as y. Y equals a. What is y? Well, he's a. That's all he can be. Okay? So he's a. Now, if I was using, it's really hard to write just one thing in interval notation. If you are using proper set notation, you might write this as, with your little brace, any a such that, or any y such that y is equal to a. All right? But we're not. We're just going to write a. Okay, so the next one is the identity function. The identity function. the equation looks like this. F of x is equal to x. It keeps its identity, all right? It's going to contain the points that where the y and the x are the same, all right? So it's going to contain the points like 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. So actually what it makes is that it makes this diagonal right here, okay? See, here's my 0, 0, my 1, 1, 2, 2, 3, 3, 4, 4. Okay, let's talk about the domain. The domain, this line right here, it keeps going down, but what else does it keep doing? Yeah, it keeps going left. So my domain is from what? Negative infinity to what? Positive infinity. Very good. Negative infinity to positive infinity. It keeps, even though it looks like it's going down, it is going down, but it's also going to the left. So x can be anything that you want to be. What about my range? With respect to the y-axis,
Oh, it's 0, right?
where does he go?
Oh.
All the way down, what is that? Negative infinity to all the way up. What's that? So that's negative infinity to positive infinity. Okay? Absolute value function. This is kind of what we're talking about today. F of x is equal to the absolute value of x. These are called parent functions. All right? These are the simplest function that you can get. Like I'm not doing anything to it. I'm not moving it around anywhere. I'm not stretching it or compressing it. I'm not doing anything to it. It's just an absolute value function. If you graphed it, this is what it would look like. A V. It would look like a V. We're going to talk about absolute value today, but I think you already know about absolute value, so I'm going to go ahead and tell you where this graph comes from. So, let's go 0. What's the absolute value of 0? So there's that point, 0, 0. Okay? What about 1? What's the absolute value of 1? So it contains that point, 1, 1. What about negative 1? What's the absolute value of negative 1?
1.
Yeah, so at negative 1, it's also up there at positive 1. At 2, it's 2, and at negative 2, it's 2. You see it? Okay, so let's talk about my domain. My domain is, where does this graph exist on this x-axis? Well, again, he's going up and out, so it's going to be from 2, very good. Negative infinity to positive infinity. All right, now notice that every time that I started talking about the domain and the range, that I have started with the domain, I have started with the left. Okay, now.
Ms. Davis,
Yes?
I need Emily Borum to the front office to leave, please.
Okay,
Thank you.
so, hey Emily, do you have that other worksheet, 1.7? All right, so the reason I start with the left, even though most of you are like, oh, okay, she starts with the left because that's the way we read. But I also start with the left because anything in interval notation, what do you know about the left hand? This should be my smallest number. Okay, the smallest number should be on your left in interval notation, and the largest number should be on your right. All right, everybody got that? Okay, so when I'm doing the range, that's why I'm starting at the bottom, because those are my smallest numbers, and then I'll go to the top, and that's my largest numbers. All right, so when I start talking about the range and I read my graph, that's what this is called, then I start from the bottom, and I read until, and that's where my graph starts. So where does it start?
0.
At 0. Is that 0 included or excluded? Included, right? Because the absolute value of 0 is 0. So that is that point right there, 0, 0. Comma, all the way until you get, it keeps going up forever and ever. What is that? Positive infinity. Very good. Okay, so the next one is called the square root function, and it is exactly what you think it is. F of x is equal to the square root of x. Okay, now I'm just going to teach you a little trick on this one, because sometimes, you know how when you get on a test and your brain just goes, boop, and you're, oh, dang, oh my word, I knew that and now I can't think of it. Well, you can figure it out, okay? Let's see how to graph this. First of all, I'm gonna start over here on the left. These are negative numbers. Can you take the square root of a negative number?
No.
No. Y'all, you can't, okay? Like, what is the square root of negative 1? What number do you, 1? 1 times 1 is positive 1.
Syntax error.
What about negative 1? What's negative 1 times negative 1? 1. So I can't take the square root of a negative number, okay? So this thing, it doesn't even exist over here on this side, all right? What about 0? Can I take the square root of 0? Yeah, what's the square root of 0? 0. So he must start right here, okay? So what about 1? What's the square root of 1?
1.
All right, so at 1, it must be 1. All right, I don't like 2 and 3 because I'd have to know what they were, and I don't really. Okay, what about 4?
2.
Okay, so at 4, he went up to 2. And then I go, oh yeah, I remember what that looks like. He looks like this right here. And y'all, actually what it is, it's like the top half of a sideways parabola. Okay? It's like the top half of a sideways parabola. The other part would have been down here, but it's not there. So this is what a square root function looks like when you graph it. Can you tell me about his domain? It starts at 0. Is the 0 included or excluded? Included. We took the square root of 0, okay? And it goes all the way to what? Positive infinity. Because we can take the square root of 2 and 3, but they're decimals, okay? So we're like, nah, I don't want to do that. So let's talk about my range. You're starting down here, reading on the y-axis. Where does it start? 0. And again, it's included because the square root of 0 is 0. And then it goes where? Up. Yes. And it does go all the way to positive infinity. It goes out, but it goes ever so slightly up. Okay? So, positive infinity. And we know that infinities are never included, right? All right, so we got one more. One more. This is a quadratic function, okay? It is f of x is equal to x squared. All right, when you graph it, it looks like a parabola. Make sure you put these arrows on your graph, because if you don't, I'm going to take off for that, okay? If you don't put an arrow, then you're telling me it stops right there, and it doesn't. It keeps going, all right? So this is my quadratic function. F of x is equal to x squared. Let's talk about the domain. Where does this function goes up on each side, but it also goes what? Out. Okay, so what is my domain? Yes, negative infinity to positive infinity. Okay, negative infinity to positive infinity. What about my range? Start from the bottom and read up. Where does it start?
0.
Is that 0 included or excluded? Included. Yeah, he's included. All right? And it goes all the way to what? Positive infinity. Yes, very similar to absolute value. Really, the only difference in them is that this is a straight line V, right? And we call an absolute value function a V graph, and this is a curve. Because anytime you have an exponent other than a 1, it's going to be a curve. Value V. Value makes a V. Alright? Okay, anybody got a question? Okay, tell me when your test is. Tuesday. Okay? So for the sake of this video, I'm putting Tuesday, Wednesday. B days will be Wednesday, Tuesdays will be A days. Yes? Everybody got it? Okay, so let's do our 1.7. So 1.7, we are going to be talking about absolute value equations. Yes? Yeah. sheets, right? Okay. Equations and inequalities. We're only going to talk about the equations today, okay? We're not going to get to the inequalities. Bye. Good luck.
Thank you.
All right? Absolute value, equations, and inequalities. Okay. Tell me what you know about absolute value. It's always positive. Okay, that's most of the time what kids say. Well, it's always positive. All right, I used to teach it that way. I used to say, until I had that little smarty kid in my class, you know, and he said, what about zero, Miss Davis? That's the value of zero is zero. Is zero positive? Is it?
No.
No.
Zero.
So can we say and be right that it's always positive?
The exception is zero.
Okay, the exception is zero, but we're not English people, right? That's what English people do. I before you, except after seeing 9,000 other times, right? Okay, so, but could I say this and be correct? Absolute value is never negative. Is that true? Okay, so after that kid said that, I was like, well, you know, really, I mean, he was right. It's not always positive, but I can say that it's never negative. So what does absolute value represent?
How far is zero?
That's exactly right. How far I am away from zero. The distance that a number is from zero. And that's why it's never negative, because distance can't be negative. Okay? So, this is the way we write absolute value. Okay? And I'm fixing to write the technical definition of absolute value. Alright? And I'm going to tell you why some kids don't like this. Okay? So first of all, the absolute value of x. The absolute value of x is equal to x if x is greater than 0. Is that true? Well, I don't know. Let's pick me a number that's bigger than 0. 4. What's the absolute value of 4? 4. Well, that sounded true. What about another? Pick me another number. 36. What's the absolute value of 36? 36. Okay? So it has to be greater than 0 for this to be true. What about, let's pick a fraction. What about 2/3? What's the absolute value of 2/3? 2/3. Okay, so this is good. Do you agree?
Yes.
Okay, so what about this? The absolute value of x is equal to 0 if x is equal to 0. Is that true?
Yes.
Yeah, the absolute value of 0 is 0. Okay, so that's pretty good. All right, what about this one? This is the one that kids go, no, I think we just said, all right, the absolute value of x is equal to negative x if x is less than 0.
Yes.
What about that makes you say no?
Because it seems wrong.
Yeah, because we just said it's never negative.
I was gonna sing happy birthday.
Oh,
I didn't know it
thank
was your
you.
birthday.
Yes, yes,
Okay.
it is.
Anyways.
Thanks, Montana.
You're welcome. Bye.
Bye-bye. All right,
I
so,
Happy birthday, I've never said it.
yeah, it's my birthday. So, absolute value of x is equal to negative x, and as soon as I say that negative, your brain goes, oh, no, 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 no.
Because if x is a negative number, then the negative cancels out.
That's exactly right. Okay, so here's what Cole says. Cole says, it says if x is less than 0, so I'm talking about a negative. So what's the absolute value of negative 2? 2. What is negative 2? 2. Or I like to read it this way. What is the opposite of negative 2?
2.
Yeah, you see what's happening there? All right, so let's do another one. What about negative 7? The absolute value of negative 7 is what? 7. What is the opposite of negative 7? 7. So this is a good definition. Do you agree? Looks a little crazy, and this part right here makes people go, oh, I don't think that's right. But this negative is going to make the number that's negative that you put in there positive. All right, so let's talk about it in another way. What if I told you that the absolute value of x was equal to 5?
That's great.
Tell me what x can be.
5, negative.
Oh, Cole says 5 or negative 5. What? That's true, isn't it? The absolute value of 5 is 5, and the absolute value of negative 5 is 5. Whoa! What if I told you that the absolute value of y was equal to 14? What could you tell me about y?
It's either negative 14 or 14.
Yeah, it's either negative 14 or 14. So here's what I'm seeing with these absolute value problems. How many answers could they have?
2.
2. Do they always have 2?
Not necessarily.
Not necessarily.
Zero.
Yeah.
Yes?
Yes.
What?
Zero doesn't have.
Oh, Juliana said, what? The absolute value of x is equal to 0 when? When x is equal to what?
Zero.
0. That's not 2 answers, that's just 1. Okay? What about this one? Absolute value of x is equal to negative 4.
That's two.
That's when it's negative.
Be one.
That's not right.
That's 4? What's the absolute value of 4?
Wait.
Or that's.
Oh, that's not 4.
So it's the opposite.
Negative 4? What's the absolute value of negative 4?
Four.
4. Oh, nope.
Is it the
negative
exponent?
outside the,
Is it the exponent?
is the negative the outside the?
It's opposite. This is like,
What did you just say, y'all? What did y'all say about absolute value? It's what?
Maybe negative.
It's never negative. Alexa said, we just said it's not
That's not
negative,
true.
people.
Not true.
So,
No solution.
no solution. Null set, empty set, no solution. Guys, listen to me. I'm gonna give you a question like this on the test. Should it take you 3 seconds and you write the answer down and don't even have to do any work? Do you agree with that?
Yes.
Oh, but guess what? Some of you are not going to do that, okay? But it's okay, because I'll show you how to fix it. All right, so here we go. There are 4 of them. These are the rules to solve an absolute value equation. Okay? The rules to solve an absolute value equation. Now listen to me. If I picked up my algebra book and I looked in section 1.7, chapter 1, section 7, would it list the 4 rules? No. People, the book doesn't tell you stuff like that. You have to figure that kind of stuff out yourself. Okay? These are the rules that I made up myself by working problems. Okay? Did you know that when you go to college, that when you go to class, the teacher's not going to teach you how to do the stuff? Did y'all know that?
we're going to give you the word.
They're not. Okay? Like if you were supposed to come to college class today, then on the syllabus it would say we're going to do 1.7. Okay? And so when you came to class and I was the college teacher, I would say, does anybody have a question about chapter 1, section 7?
No? Crazy. All right.
And if you haven't ever looked at it, are you going to have a question? No. And if you've never looked at it and other people ask questions, will you even know what they're talking about? No. So when you go to college, your job is to look at the material before you come to class. Okay? And that way if you have a question, you can say, I have a question. What if you have a problem like this? I didn't know what to do. And the teacher will answer that question. Do you understand? But y'all listen to me. When you get to college in math, they're not going to teach you the stuff. They're going to expect you to learn it. That means that you have to be able to look at a book and read it and figure out how to do it. Do you know what we do in here every day? We work the examples that are in the book.
Yeah.
Sometimes I'll add some stuff to it because I see mistakes that kids make all the time. And I'll go, you know what? If we did one more like this, I could address that before they made that mistake. Okay? But, I mean, I'm basically working the examples that are in the book. Are they worked out in the book?
Okay.
Yeah. Yeah, they are. Oh, they're all worked out in the book. I'm gonna show you. Okay? So, let's see, what, we just did 1.6, right? Okay,
Is
so,
that the teacher's edition or the student edition?
it doesn't, it's a teacher's edition, but it's, it only is a teacher's edition because we, I mean, it has answers in it. It still looks exactly like y'all's. It just, the only thing that looks different is, oh no, I'm sorry. This is a kid's book. It's not a teacher's. Okay? Look, example 4. That's what you did. That's what we did.
It tells you how to do
We
it.
got all X's. See, they tell you right here. We showed our work and did it. okay? We didn't write these words beside it, but they still tell you how to do it, right?
Yeah.
Okay, see, here was one. This was a compound inequality, an and statement, right?
Yeah.
Okay, write it, add 10 to each expression, plus 10, plus 10, plus 10. Remember how we talked about there was 3 sides? Okay, so that's what you're gonna have to do when you get to college. You're gonna have to look at your own book and figure that stuff out. All right, so here we go. Number 1, these are the rules. There's 4 of them. The first thing you're gonna do is isolate the absolute value. I would say this too, that your Algebra 2 notebook would be a big help if you were taking a college algebra class, okay? It's gonna have a lot of things you might wanna look back over and say, oh yeah, that's what we did. All right, what does isolate mean?
Get by itself.
Yeah, get it by itself. So you're gonna get this absolute value all by itself. You know how to get rid of stuff. If they add, you subtract. If they subtract, you add. If they multiply, you divide. Do y'all remember all that? Okay, so here's the second thing. You're going to set up case 1 and case 2. Notice I'm using Roman numerals, okay? If I use regular numbers, they're really called Arabic numbers. All right, those are the ones that we write with. The kids are like, what? Those aren't Arabic. Yes, they are. That's what they're called, okay? But if you use Arabic numbers, it might get messed up with your problem. So I use Roman numerals, okay? Case 1 and case 2. Case 1 is going to be the positive value, and case 2 is going to be the negative value. All right? I'm going to show you how to do it. It's going to be okay. Number 3, we're going to solve it, each one of them. And number 4, you're going to check. Okay? You're going to check. This 4, very, very important. Okay? You're going to find out why checking is going to be important. Okay, so let's try a problem. You ready? All right, so here's the first one. Example 1. 2 times the absolute value of x minus 5 is equal to 14. Okay, so the first thing I have to do is isolate the absolute value. Tell me what to do.
Subtract the 2.
Yeah, do what?
Subtract the 2. No,
I gotta get rid of this 2, right? What did they, if you don't know what to do, you ask what? What did they do with the 2 in the absolute value? They multiplied, so what do you have to do? There you go. That's how you know what to do. If you look at it and your brain doesn't go, oh, do this, then you go, oh, wait a minute, I gotta get rid of the 2. Now y'all listen to me. You can never, ever distribute through an absolute value. Okay, that's totally wrong. Here's another thing that's totally wrong. You cannot say that this minus sign is inside the absolute value, so he becomes a plus sign. No. You can never do that. Is that mine? All right, so you're going to divide both sides by 2. All right, so y'all do that. Let me get the phone. I ain't got time to be answering the phone. Hello? Sure. All right, bye-bye. Savannah, where did she go? Dang it. What's his number? Does it have a readout?
It should.
I don't see any kind of readout. How are these listed? You're kidding me. They only put teachers on there, they didn't put administration. That is ridiculous. I don't want to call it. There's front office. Hey, Tana, it's Billy Gay. I don't know, somehow we don't have any kind of, I don't have a number for Steve Lisby. And he just called me and asked for someone, but she left with volleyball. Savannah Crabtree. Yeah, she's gone to volleyball. All right, thanks so much. Bye-bye. be something I need to fix, sorry about that. Okay, so everybody divided by 2, over here on the left, it's gone. I'm left with the absolute value of x minus 5 is equal to 7. Are you with me?
Yes.
Okay, so the next thing I'm gonna do is I'm gonna make up my cases, okay? This is the only time I'm gonna write the word case. After that, I'll just start writing a Roman numeral 1 and a Roman numeral 2. Okay? Now, here's what you told me. Look up here for a second. You told me that this, whatever is in this absolute value, is equal to this number positive and this number negative. Do you agree?
Yes.
That's what we're fixing to do. Okay? So case 1 is going to be, take the absolute value signs off, people. Don't ever put them down here. So it's going to be take what's inside there, x minus 5, equal to a positive 7. And case 2 is going to be x minus 5 equal to a what? Negative 7. Okay? Now, look, I'm going to make this little note right here. No absolute value symbols. Okay? Once you get down here, don't be putting those absolute value symbols on your cases. All right? Never put them on the cases. Always leave them off. Now we're just solving each one of these. So let's solve this one. How do I solve for x?
Plus 5.
Plus 5. On the left, it goes away, and x is equal to, what's 7 plus 5? 12. All right, now I'm going to do the exact same thing on the right-hand side. Plus 5 and plus 5. X is equal to, what's negative 7 plus 5? Negative 2. Okay, now what did the next thing say you have to do? Check it. You have to check it. Okay, now y'all listen to me. I told you to check your stuff on your test. Some of you did not check your stuff on your test. Okay? If you missed an equation, you should not have, because you should have checked it.
It's, okay, if you get it right, is it 1? Like, if you put it back in your calculator and you plug in the x that you got, would the answer that you get on the calculator 1 if it's right?
No, it would be whatever it was set equal to.
Okay.
Okay?
Okay.
Like watch, I'm gonna do this problem. I'm gonna check 12. I'm gonna plug 12 in right here. Now, really, it would be easier for me to do it in my head, okay? But I wanna show you how to use the absolute value symbol on your calculator.
Oh,
Okay? So there's 2 places that you can get the absolute value symbol. Can you tell me one of them?
Math?
No? Which one have I taught you?
No. Catalog.
Catalog.
That's what it is.
Catalog. Y'all listen to me. If you don't know if your calculator's gonna do something or you forgot where it is, go to the catalog. Second in catalog. It's in alphabetical order. Guess what the first thing that pops up is? Absolute value. Okay, so that's one place to get it. I'm gonna show you one other place. Y'all, there's probably 5 places. I don't care. If you wanna waste your time finding them, you can. But all I need to know is one, okay? So the other places, this is where I use it, alpha and F2. Okay, and see, that's the very first thing, the absolute value. So that's the one that I'm gonna use. Are you ready? Okay, so I'm gonna put this in, I'm gonna plug my 12 in, all right? So I'm going 2 times the absolute value, so I'll go alpha and F2, I'll choose it. X, well, I'm trying to see if 12 works. So 12 minus 5. What do I want it to be equal to?
14.
Boom. The 12 checks. So I put a little check mark beside it. What does that check mark tell me? It tells me when I look back over my test or my worksheet that I checked it and I know it's good. Okay? Not that I forgot to check it and I don't know if it's good. All right, so now I'm going to check the negative 2. So I'm going to go 2 times the absolute value of negative 2 minus 5. 14. So he checks also. So watch this. Here's what I want you to do. My solution set is the set containing 12 and negative 2. The order that they are in does not make any difference at all. okay? The order that they are in does not make any difference at all. This is my solution set. All right, let's do another one. Are you ready? Okay, so this is example 2. Example 2 looks like this, absolute value. Absolute value of 5x minus 10 minus 5 is equal to 40. Okay? Tell me what to do.
Combine your like terms first.
Do what?
Isolate.
Isolate my absolute value. By doing what? Adding 5 to both sides. Okay? What's outside the absolute value? Y'all, you cannot get rid of anything that's inside. Okay? What's outside? Minus 5. How do you get rid of minus 5? You plus 5. Alright, so now I have absolute value of 5x minus 10 is equal to, what's 40 and 5?
45.
Alright, now what am I doing?
Keep your cases.
Yeah, now I'm gonna do my cases. Okay, so here's some things. Y'all listen to me. The way that I set things up, you should probably do the same, okay? Don't be so rebellious that you're like, I'm not gonna set mine up that way. Like one kid was like, no, I'm not using Roman numerals, I'm using regular. And I said, that's really confusing because all of our problem is with regular numbers. You see what I'm saying? So that might mess you up. And he said, oh, you're right. I didn't think about that. And then another kid was like, I'm not going to put mine side by side like you, Miss Davis. I'm going to put mine one on top of the other. And then he needed to go back and fix something and he didn't have enough room. Okay? So do them like this, 1 and 2. All right? So case 1, tell me what case 1 says.
It's a pot.
5x minus 10.
5x minus 10 equals what? 45. No absolute value symbols. Okay? No absolute value symbols. What does case 2 say?
5x
Plus
plus
10
10 equals 45.
She's not here. Oh, I don't understand why they don't check why don't they check the, I don't know, whatever. So, 5x minus 10 is equal to what?
Negative 40.
Negative 45. Okay, so now I'm just gonna go and solve each equation. Guys, should you be able to solve an equation?
Yes.
Okay, so over here on the left, I'm gonna add 10 to both sides. 5x is equal to, what's 45 and 10?
55.
Okay, now what am I gonna do?
Negative.
Divide by 5. And x is 11. Very good. Over here, I'm gonna do the same thing. I'm gonna add 10 to both sides.
Negative
5x is negative 35. Divide by 5. And x is what?
7.
Negative 7.
Oh, yeah.
Very important, right? Okay, so now what are we gonna do? Yeah, you better check them, okay? So I'm gonna check them, so I'm gonna say absolute value. 5 times 11 minus 10. Go outside the absolute value and say minus 5. What should it be equal to? 40. Boom. Each x. Okay? Now I'm going to go back in. I'm going to show you a little shortcut. Okay? Because I don't want to type all that mess again. I'm going to go back up here and I'm going to grab this problem. And then I'm going to arrow back into the problem and I'm going to change it. Okay? Now I'm going to do one thing. I'm going to just delete this and pretend like it was a 1 right there because I really need to put a negative 7. So here's my negative, but do you now you see if I type this 7, I'm going to have to retype the whole problem, right? Okay, so I'm going to show you how to insert a 7 right there. Just like this delete button deletes whatever, just where the box is blinking, above the delete is INS, and that's insert. So if I go second and insert, then it becomes, instead of a blinking box, it just blinks on whatever it's on. And I can insert a 7 right there. That one's 40 also. So what is my solution set? 11 and negative 7. Would it be wrong if you wrote the negative 7 first?
No, ma'am.
No, it would not. The order doesn't matter. It's just a set. okay? Anybody got a question so far? Okay, so I'd like to give you a little bit of time to work on your worksheet, but, I mean, we still have, what do we have? Like 2 more problems to do, okay? And then, we'll be through. I've never had so many visitors this period. It's okay. She's gone with volleyball.
Oh my gosh.
Okay.
She was like,
Savannah probably snuck out with her.
Honestly,
Thank you.
Okay, so here we go. Example 2B. Are you ready? You on your game? Here we go. Negative 2 times the absolute value, x plus 3 equals 18. All right? Let's see how good you are. I'm going to give you 1 minute to work this problem.
Problem written down here.
You got it? All right, everybody okay? Okay, so watch up here, because that took you entirely too long, all right? Watch this. Do you agree with that?
yes.
No,
And this?
Oh, divided.
Y'all listen to me, if you added 2, would that get rid of this?
No.
Y'all, that would not get rid of this. You would end up with negative 2 times the absolute value of x plus 3 plus 2, okay?
Okay.
So that would not get rid of, adding 2 will not get rid of this negative 2 because this negative 2 is multiplied. How do you get rid of something that's multiplied? You divide. And what you do to one side, you do to the other side. Okay? So now my problem looks like this. What's 18 over negative 2? What are we going to do now?
Then make your cases. I knew it.
Why? Why do I want to make cases? Because I told you, didn't I just tell you?
It can't
I
be-
said absolute value can never be what? Negative.
Oh.
So when is this ever going to work? And I told you, guess what? I'm going to give you one of these on the test and what?
I'm gonna forget it.
You're going to forget. Like it's a giveaway problem, people. Okay? So let's see what happens. What happens if I end up with this problem right here?
I did it and it gave me syntax error and I did it.
Oh, okay. So let's see. If you had a syntax error, you were using a minus sign instead of a negative sign. That's a syntax error. Y'all listen to me. If your calculator says, watch, I'm going to show you something. You need to know this. So everybody look, okay? If I say, if I use this minus sign as a negative, and I say minus 3 plus 6. Oh, stop. If I say minus 3 plus 6. Oh, he's pulling the answer. You know why he keeps pulling that answer? Because you can't do that. So what if I do this? What if I say 3 plus and
Just hit 3 times, just hit 3 multiply and then put it in.
Minus 3. It still won't let me do it. Multiply with it, and it won't do that?
Just hit a
Minus
random number
3
and then
times,
put
it still keeps pulling the answer.
Are you trying to get the syntax error to show up?
Yes.
Then just hit a random number and then the multiply button and then enter.
Oh,
The negative.
okay. Well, I was trying to show you that the calculator will not use this minus sign as a negative sign. Okay, but, okay, I'll do that 3 times. That's a good idea. Okay, so now he says, oh, you have a syntax error. Do y'all see that second thing where it says go to?
Yes.
Arrow down to it, and then press enter, and the calculator will take you to the arrow. He's saying, oh, lady, who do you want to multiply 3 by? Okay? He doesn't know what to do. The syntax error means you've given him something that he doesn't understand. If it's an older calculator, like if you're using one of my class calculators, and you use a minus sign instead of a negative sign, all right? Like if I'm trying to say -3 plus 4 or something. Notice this new fancy one. When I pressed this minus, it assumed I wanted to use the answer of the previous problem, so it kept pulling that down. So normally that's the way I show kids, but I forgot I had a new fancy calculator. All right, so what if we started right here? Could we make my 2 cases and then discover that we still know how to do the problem? Yes, we can. So case 1, do you agree it's x plus 3 equals -9?
Yes.
Because really, all you're doing on case 1 is removing the absolute value signs, right? And case 2, you go x plus 3, whatever's in the absolute value, equal to, and you take the opposite of this side. Okay, you change his sign. So what's he going to become then? +9. All right, so let's solve it. Over here on the left, I get -3, -3, right? So then that's when you can add and if they add and subtract, that's what you do the opposite, okay? Don't be adding and subtracting when they multiply. So then I got x is equal to what's -9 minus 3.
-12.
Okay. Over here I'm going to subtract 3, and x is equal to what's 9 minus 3. 6. Now what did I tell you to do?
Plug it in.
Yeah, you gotta plug it in and check it. So watch what happens when I try to check this guy. You're fixing to learn a very important lesson and a new word, okay? So I'm going to take the absolute value, and I've got -12 plus 3. And I want it to be -9. Well, it's not -9. So did this guy check?
No.
So here's what you do. You put an X on it. Did you hear me? If it doesn't check, what do you put on it? An X. Do you scribble it out where I can't see it? No. Do you erase it because it doesn't work? No. You put an X on it. Okay, so let's check this guy. Absolute value of 6 plus 3. Not -9. Okay, so I'm going to put an X on him. So neither one of them work. What's my solution?
No solution.
Null set, empty set, no solution. Okay, now these have a name. Okay, these have a name. They're called extraneous, EXTRANEOUS, solutions. Extraneous solutions. An extraneous solution is a correct solution. Okay, a correct solution that does not check. Okay, correct solution that does not check. Huge emphasis on the word correct. Okay, because y'all listen to me. As soon as I do this first problem right here and it doesn't check, what does my brain scream at me? Yeah, you did something wrong. It didn't check because you did something wrong. So even if I went back and looked at it, I'm like x plus 3, -9, subtract 3, minus 3. Like signs, you add, takes out a both. No, I didn't do anything wrong, okay? So it was a correct solution and it didn't check. That's an extraneous solution. Now, the reason I'm making such a big deal out of it is because if I had said -9 minus 3 equals -11, would that have checked? Listen to my question. My question is, if I said -9 minus 3 is -11, and then I used -11, would it have checked?
No.
No. Is it because it was extraneous?
No.
It's because it's what?
Wrong.
Wrong. Okay? So here's the big thing. All right? As soon as I get something that doesn't check, my brain goes, ooh, you're wrong. You made a mistake. I'm going to say, well, I don't know. Let me go back and see. And so I go back and I check my work. And if my work is all correct, then it's correct. But here's what happens. Sometimes kids get the wrong answer and it doesn't check. And what do they say? Oh, he's extraneous. I'm like, no, he's not extraneous. He's wrong. Okay? And listen to this. If this were your problem and you didn't see it over here, and you had these answers, but right here you had a -11, even though this is correct, I would have counted points off. Because your -11 is not extraneous. It's wrong. You understand?
Yeah.
Okay, so that's why I don't want you scribbling it out, because I'm going to have to read it. If I can't read it, I'll count it wrong. All right? So it is a correct solution. If you solve the equation, you do get it, but it will not check for some reason. Okay? All right. What if, okay, so here's what I get. Sometimes kids will be like, oh, if I got a negative on this side, if my absolute value on that side, and I got a negative on this side, then my answer is null set. Is that always true? I don't know. What if? Okay, what if you ended up with a problem like this? -2 times the absolute value of 2x minus 5 is equal to -6. Can I just bust out and go, oh, null set?
No,
Why?
because it's multiplied by a negative number.
That's exactly right. This -2, well, how are you going to get rid of this -2? Divide. And when you divide both sides by this negative, this cancels out. But now look what I got. What's -6 over -2?
3.
So now you know it's not the null set, okay?
So
I can find numbers to put in there so I can take their absolute value and find 3.
Is it when you divide by a negative? Like,
No, because I divided by a negative.
well, no. Like, if you divide by
No,
a
not
negative.
necessarily, because if I had a positive over here and I divided by a negative, it would have ended up being, that's what happened here.
That's what I'm saying. If you have a positive number equal to.
No.
Okay.
You have to isolate the absolute value. If the absolute value is isolated and it's equal to a negative number, it's the null set. Absolute value will never be negative.
Yeah.
Okay? But this is not just an absolute value. Okay? This is an absolute value times a negative. You gotta get rid of that. You have to isolate it first before you can decide. Okay?
Yep.
One more problem, and it's gonna have a little bit different skill on it, and then we'll be done. Yes, Ace, you got a question?
I'm just doing the target, not the head.
Oh, okay. All right, so this is example 3. It's the last one. And I'm not gonna do the second half of 1.7, because I don't have time. And I'm gonna give you a little bit of time to work on your worksheet. Absolute value of 2x plus 12 is equal to 4x minus 3. Okay? Now, I really kind of like this problem because he's gonna address a lot of issues. All right? So the first thing, tell me what the first rule is. What do you do? Okay, isolate your absolute value. Y'all listen to me. When you get your test and you look at it, it says solve this equation, as soon as I see the absolute values in my equation, my brain goes, oh, these are the ones where we have 2 answers, 2 possible answers. See what I'm saying? Okay? So don't just make one answer because you'll miss half of every problem that's on there. Okay? All right, so case 1 and case 2. He's already by himself. All right, so what does my case 1 say? Uh-huh. Equals 4x minus 3. Very good. Okay, now, what about case 2? 2x plus 12 equals, what's he going to equal?
-4 minus 3.
3.
Oh, I like that, because look, when you make this side negative, y'all, it's just like this. You got to do this. And you have to distribute that negative throughout the parentheses. You have to change every sign over there, okay? So he's gonna be equal to a negative 4x and then a positive 3. Okay? So I'm gonna go back over here on the left at case 1 and I'm gonna solve for x. So I'm gonna put my x's on the right because he has the most. So I'm gonna subtract 2x from both sides. Are you with me?
Yes, ma'am.
So 12 is equal to, what's 4x minus 2x? Now what am I gonna do? I'm gonna add 3 to both sides, good. And I got 2x is equal to, what's 12 and 3? 15. And now what am I gonna do?
Divide by 2.
Divide by 2. And what is x equal to?
15
No!
No, it's a
No! Stop making decimals, people. Don't give me decimals unless I give you decimals. Do you understand?
Yes.
I'm tired of writing frowny faces on your paper. We're fixing to start that second 6 weeks. Okay? And I'm fixing to start saying, oh, so sad, -2. Stop. Stop it. Okay? So, tell me what the answer is.
7.5.
No!
15 over 2.
Yeah, it's 15 halves. Thank you, Charlie. 15 halves, people. Okay? It's just 15 over 2. Can you reduce that fraction? No, so that's it. I don't want a mixed number. If you have a mixed number and you got to put it back in, if you didn't have some fancy calculator like you got, you'd have to turn it back into an improper fraction. Okay? All right, over here. Going to do the same thing. I'm going to add my 4x though, because I'm going to put them over here. So plus 4x and plus 4x. So 2x and 4x make what? 6x plus 12 equals 3. Now what are we going to do?
Subtract 12.
Yeah, subtract 12. So now 6x is equal to, what's 3 minus 12? Negative 9. Now what am I going to do?
Divided by 6.
Divide by 6. So let's see who's been listening to me. X is equal to. People, am I going to pop this in my calculator and write some dang decimal down? No. Okay? Is my answer positive or negative? Negative. Can you reduce this fraction?
Yes.
And if you don't, I'll take half credit away from you.
3.
Okay? 3 goes into here 3. 3 goes into there 2. So 3 halves. Okay? Now what am I going to do?
Plug them in.
Check.
I'm going to plug them in and check. Okay? So I'm going to plug this guy in. Okay? Now listen, if you haven't plugged any in and checked, should you practice that skill? People, you better, because it's not. I mean, I'm doing it all. Do you get better when I do skills? No, you get better when you do skills. All right. So, y'all listen to me. When you're checking something, you always go back to the original problem. Do not check answers in something that you've messed with. Okay? So you go back to the original problem. So alpha and F2, and I'll go 2 times, don't use parentheses to multiply. Okay? 15 halves. If you want to, you can go alpha and F1 and get you a little fraction there. Put a 15 on the top and a 2 on the bottom. Get out of the fraction, and then go plus 12. So that's 27. Now we go to the other side and we plug it in, right? Because this is one of those you have to do both sides. So I'll say 4 times, get me a little fraction, put a 15 on the top and a 2 on the bottom, and then go minus 3.
Oh, that's kind of tedious.
27. It is a little bit tedious, okay, but I'm going to tell you this. It's a whole lot better than you doing it by hand, although you would learn more by hand. So, does he check?
Yes.
Yes, he does. So I like this guy right here, okay? Let's check this guy. So I'm going to go, I'm not going to, well, let's go back. Might as well go back and cheat a little bit, all right? Pull this guy back up. I'm plugging negative 3 halves in, so I'm going to arrow that. And so negative 3. It had 2 digits there, so it let me plug it in real nice. I didn't have to insert anything. And it's already over a 2, so I'll just press enter, 9. And then I go do the other side. Well, again, I can cheat if I want to. All right, I'll pull that other problem down, arrow back in here, and go negative 3 over 2. And then press enter.
Negative.
Whoa, No, what do I do to him?
X.
Put an X on him. Now, watch this, watch this. What is my solution set?
5 and 2
Negative. No, that's, yeah, okay.
That's all. This is not, this is an extraneous solution, y'all. He does not check. Don't put him in my solution set. Don't put him in my solution set and then X him out. That's crazy. Okay? He's not a solution. All right, anybody got a question? Okay, so on the worksheet that I'm fixing to give you, you can actually work the whole first page. Okay? Now, here's what I'm going to warn you about. Okay? I told the kids, they said, well, how much do we need to do? And I said, you need to do at least half of the first page. Okay? Because here's what's going to happen. Next time you come to class, I'm going to finish this section, and if I have time, I will start on 2.1. If I start on 2.1, I'm going to give you another worksheet. Do you understand?
Yes, ma'am.
Okay, so at least have half the first page. I would do all of the first page if it were me, okay? And then you will just like the second page, okay? And then you want, but y'all, with this next test, there's only 2 worksheets. There's this one and the next one. I'm done with the 9 bazillion worksheets,
Thank you.
okay? So, I know. Does that only punish you when I give you 9 bazillion worksheets?
No.
It punishes me too, because I got your grade.
I know,
Yeah.
I'm thinking about that all the time, cause this was not our class too.
That's right. I have 4 classes.
And then pre-cal worksheet.
Yeah, pre-cal. So,
Like grade 9.